Okay, so it's 4:01. We'll start our webinar today. Our guest is or are Jaime and Sam from YNSAT. I'll let Jaime or Jamie, as we call him here in Toronto, introduce themselves and tell us a little bit more about the company and the tools that they developed for the mining industry.
Okay, well, first of all, hello everybody and welcome. Hope we have some good timing here and you guys can get to know this technology. And well, as Nermina said, my name is Jaime. I'm the account executive here at YNSAT. And yeah, we are a company that we manage all the remote sensing for mining companies, which it could be satellites, hyperspectral, open data, high resolution, whatever. And to drones also could be airborne, whatever EO instrument. We can manage it all and make it easier for analysis, monitoring, a lot of use of cases that we will talk later. And well, basically my goal in here, I'm based in Toronto and yeah, I'm the head in Canada and just trying to gather information from the market to the platform and be at the latest in here. And yeah, Sam?
Hi, I am Sam. I'm one of the co-founders at YNSAT, and I am sort of the technical guy. So everything related to how we apply remote sensing to the mining industry, I'm just up to discuss and talk about that every time. So thanks for inviting us, Nermina, to here.
It's a pleasure to have you. So let's start digging into meat of your tool. Tell us a little bit more what your tool can do and what are the best applications.
Well, I think that first we could talk about what remote sensing is. Like, I think that's the first part, and then we'll later we'll go to our tool. But yeah, uh, remote sensing is the technology that is well. I think Sam can explain it better, like in a technical side.
All remote sensing, all the different sources of data that are not in land or are not taken directly. In this case, the type of remote sensing that we use are satellite that are within the earth, different kind of drones, also airborne. So all of these kind of data source, we manage them onto our platform and into our solution. So just to be clear, all different kind of sources that are not mainly in land there.
Yeah, and basically what our tool does is unify all the type of remote sensing and make it simple for analysis in one just platform. And from the public satellites as Sentinel that somebody may know, Landsat, or either private satellites, and work them all through the same platform and have all this information in one place. Because well, one of the problems that we have found of our clients is that sometimes it's difficult for them to manage all this type of data because it is usually very very heavy. So it is very difficult to share with team members. To download it and move it from platform to platform. So one of our main goals it is make it easier for the user. So then the people that their work is to analyze, they can spend all the time just analyzing the image, not like with all data troubles. Okay, and yeah, I think something interesting to talk about is what feels like these technologies helps in mining, like exploration, operations.
Yeah, this kind of technology, along with other different technologies like AI, machine learning models, and artificial neural network models, can help in all the different stage of a mine's life cycle, from early exploration into rehabilitation. Uh, Going through, of course, the environmental monitoring and through the operational monitoring in there. So there are for all these different phases, like that can be exploration, environmental monitoring, operational monitoring also, and rehabilitation. There are a lot of different ways that remote sensing data, along with different algorithms, can help. I don't know if you want to go just one by one, or going to talk the different aspect that remote sensing that can help through all the different cycles.
Yeah, I would suggest you go from, let's say, starting with the exploration. How can your tool or remote sensing technology can help exploration companies?
Okay, for that, I can maybe share some slides in order to express this. So let me go for this.
So in the meantime, I'm just going to say Sam is joining us from Spain. So thank you for staying late again and being with us. Jaime is in Toronto, so we don't feel sorry for Jaime.
So can you see my screen?
Sure.
Okay, so great. Let me check if I can. No, it's great. Am I moving the slides?
Yep. All good.
Okay, great. So for example, for the different cycles of a mine's life cycle, we can talk about it can help not only in this for specific points, but for large scale exploration. When we talk about remote sensing, mostly about airborne or satellite based remote sensing data, everyone thinks about large scale exploration that can help of monitoring really big areas. We are talking about tens of thousands of square kilometers, for example, in order to achieve better results. That this image, for example, enable us to cover really vast remote areas quickly, minimizing the need for expensive time consuming ground surveys. We are not talking never about eliminating the ground surveys at all, because we understand that it's something needed, of course, but we are talking about minimizing the time of the ground surveys. But the real importance for the remote sensing data is its integration. It's not just about coverage. The real power comes from the data integration with these ground surveys, with geophysical and geological data sets, that when they are combined, of course, with different algorithms like machine learning algorithms, like for example random forest algorithms, these data sets can really allows us to predict potential mineral deposits. Mm, I repeat again, never eliminating the needs for ground surveys or geological or geophysical data sets, but combining remote sensing data set with both geological data sets. Also, with the multispectral and hyperspectral imagery, that I don't know if it's like a really a common way to call how with the satellites see the world. Because, for example, just to make an explanation, multispectral satellites just can really see the world not only like we see it, but with more different wavelengths of light that we are not allowed to see. As humans, we can only see the range of the light that goes from blue to red. With satellites, you can really visualize also near infrared bands, shortwave infrared bands, or even thermal bands. This is what we call the multispectral satellites, that take different portions of the bands of the wavelength and divide it into bands. Those bands later on are able to applying different algorithms, are able to create insights in order to visualize different parts of the Earth, on how we want to specify for different insights. And the hyperspectral imagery is this same concept, but instead of separating in different bands, the bands are really narrow, and it has to be from the like a really without any jump between the wavelengths. So all the wavelengths are really, really narrow and join all of them. So you are able to really visualize much more data. So these are essential in exploration, and they help to identify unique mineral substrate patterns and the signature of the element within different wavelengths. And that, along with techniques like principal component analysis, along with, for example, with crosstalk technique and measuring the distance of the spectral with simple spectral angle mappers with different algorithms, or even with edge detection algorithms or unsupervised classification with clustering. There are a lot of different algorithms are really, really helpful in identifying different patterns on the Earth or for different elements that can be or would be missed by really traditional methods. All this is along with really well established methodologies because right now it has become a really, really valuable asset in the early exploration. There are a lot of scientific papers referring to how we can manage remote sensing data, again, along with geophysical and geological data. Do you have any questions of the early exploration phase?
I think maybe Sam is interesting to explain what an insight it is, because you have talked about insight, but maybe the people don't have it clear.
We call inside insights or simple products to different algorithms with a single algorithm that it's done with a multispectral or an hyperspectral remote sensing instrument that normally we use again drones or airborne or satellites. For that, just for example, if you take the band for the red color and divide it by the band of the blue color, you have a simple insight. Another insight also could be creating a principal component analysis of 3 or 4 bands, we call, or even it's possible to create composite insights that instead of just one channel in a grayscale, you are allowed to visualize 3 different channels as our eyes see the world in a red channel, green channel, and blue channel in order to mix different simple insights into a composite insight. Is that maybe more clearer, Jaime?
No, for sure. Yeah.
Okay,
Perfect explanation.
so question here.
Yeah.
You are able basically to analyze the surface. You cannot go below surface with this methodology, apparently. Is there a limitation to, let's say, if you have vegetation, can you filter out vegetation with this technology?
Yeah, for sure. It's possible to clear vegetation. One of the best things of using satellites, especially for exploration, is that normally the early exploration sites have been never been modified. So you have a lot of imagery from the same place. So you can filter through different kind of metadata to get the best results without vegetation or without water, without clouds, of course. Sorry. But of course, you can create different masks to mask out the vegetation and check for imagery where there is no or it's the minimum part of the vegetation. But everything in here that we are talking is about surface detections.
So if you're looking for a particular ore deposit, let's say gold ore deposit versus copper or versus lead deposit, can you filter out one against the other? I guess you're looking at different geological features. What is the outcome of your tool?
This is
Well,
well.
that's
Can I answer this one, Sam?
yeah, for sure.
Well, for example, Nermina, this is one of our more valuable thing on our platform because, well, we give some general insights, for example, some alteration maps for iron, etc. But the most interesting thing is the option of create your own insights. that is making with some mathematics with the different bands. So then you can create the insight of your benefit, because depending on the geology of the place or the vegetation of the place or whatever, it changes a lot the insight. And maybe it's one insight for that is good for gold. I don't know, maybe in South Africa is not as good as one in another part of the world. Okay, I think that explains your question.
Yeah, if you want, Armina, later on we can give an example of a really well established methodology based on a scientific paper for gold deposits in South Sudan. That's one really, really well documented scientific paper for that.
Yeah, just from the practical point of view, I'm just trying to understand and bring that out to our guests, so they can, or we can all together understand how this tool can benefit the exploration company. Okay, we are good. Please continue on.
Okay, later on, after the early exploration, we can move to the operational monitoring, what we can and how can this technology help into the operational monitoring of, for example, an open pit mine. And this is going to be related with the synthetic aperture radar satellites or drones that this plays a pivotal role in ensuring both safety and efficiency. First of all, I have to stop on what is a SAR, a synthetic aperture radar instrument. And it's an instrument that, instead of being passive, of just receiving light from the sun, like the ones that we have been talking before in here of multispectral and hyperspectral dash, they just receive the sun in different wavelengths. The SAR satellites create wavelengths, and when they bounce back to the instrument, they map. It maps the SAR satellite map the Earth surface. So, what are the benefits and the advantages and the disadvantages of this? Clear disadvantages is that we can really see different waves or wavelength of the sun of the light, so we are not able to apply the same algorithms. But one of the key advantage of the SAR is to operate in all weather conditions at any time of the day and providing really consistent monitoring without interruption. How can it be done? Because these wavelengths, they operate in the microwaves with microwaves, and they are not interfere about the sun conditions, so they can operate at night, and they are not disturbed by the clouds also. So they can operate even in cloudy spaces, and they can go through the clouds. Some of them also can go through the vegetation. And with these wavelengths, you can really visualize what is below the vegetation. So for this, these are really, really good for the surface deformation. This surface deformation, you can create different insights of surface deformation with the interferometric algorithms that helps to detect ground movements that could lead, of course, to risk such as landslide of subsidence. But they can help more than surface deformation. Also, they can enable us to monitor infrastructure stability, whether they are tailing dams, road, or other critical infrastructure and mining cycles. These particular things are not really able with public satellites because of the resolution, but with really good private satellites or drones performing different interferometric algorithms, you are able to monitor the infrastructure integrity. Also, it can track environmental impact, including change in land use, water bodies, vegetation, and different type of soils. Not as well as the environmental impact as the multispectral or hyperspectral satellites or instrument, but it also can be used for this, not only for the surface deformation or for the infrastructure integrity. Any related questions with this specific part?
So you mentioned resolution. What's the resolution with in this case?
That's a really, really nice question. It depends. For example, for public satellites, that means that are publicly available for everyone. The normal resolutions range from 30 meters each side of a pixel, up to 10 meters the side of a pixel, something similar. So that's why they are so good for really large areas. But if you want to focus on really small areas, you have to go for private providers that can go as low as for satellites legally as low as 0.25 centimeters per size of the pixel.
Oh wow,
That's
so
crazy,
that
huh?
would be for the that would be good for tailing them monitoring stability, I guess.
Yes,
Or
but
kind of.
that is normally done with lidar drones, or well, yes, mostly with lidar drones that they can have a resolution of 1 centimeter, and applying interferometric algorithm, you can have millimetric instability measurements there.
Okay, very good. And in terms of the sampling, frequency of sampling, is there a limit there, or recommended sampling rate? Like every so many minutes, you can update the image.
That's also a really nice question. Again, it depends on the provider. For public satellites, the one that is most used is the Sentinel-1 from the European Space Agency. That it goes well. It used to go for every 5 days. Now, because they have two pairs of satellites, now there is only one. But they should launch it on this year or at the first quarter of the next year. The replacement of the satellite that broke in 2022. And it's between 5 days to 10 days. But for high resolution providers, we work with a really, really good partner that offers multispectral and SAR imagery, that they only work from near equatorial orbits, from 13 north to 13 south, only on that range of the area. But thanks of the narrow latitude they cover, they can offer up to 4 times per day of revisit time. So you can have up to 4 times in the same day that you can have an image from them in the same place. So that's the good part of having such a narrow latitude band.
Okay, so I guess you would have to or companies will have to resort to drones if they are outside of certain reach, satellite coverage, I would say.
For that specific, yes, but we also work with other providers. I just was mentioning this one because I find it really interesting. The narrow latitude comparing to the high revisit period. But we also work with other providers that can give you 0.3 meters, yes, 25 centimeters, 0.3 meters of resolution each 4 to 5 days also.
Okay. Okay, thanks.
Okay, so also not only for these two parts, but also environmental management is another area where remote sensing proves invaluable. Not just because right now most countries ask for the mining industry to provide the data on how they change the environment they work and how they are going to mitigate those changes, but also because you are allowed to have near real-time monitoring that can track health of land, water, and vegetation that surrounds, of course, the mining areas. That allows the people working there to make decisions minimizing the environmental impact. When we talk about, for example, satellites again, we talk about near real time. Near real time is a range between 45 minutes up to 2 hours from the time the satellite has taken the image until you are processing it. That's normally what it's called near real time, and those are the best times that you can have the image. The fastest time that in most cases you can have the image from taking. One thing is that satellites, of course, can help in detect pollution, whether it's contamination in air, this one is the most difficult one, in water, or even, of course, in soil. Satellite data allows the mining to maintain the mine part to maintain a safe environment. Also, not for the mine pit, but also for the local communities and ecosystems surrounding the areas. Also, just in addition to the pollution detection, or the satellites can also help monitoring biodiversity. That ensures that critical habitats, for example, a specific part, if you want to, you can just monitor this specific part. That is, and to make to be sure that they are protected from the mining related impacts. You can just monitor a specific part. And finally, of course, regulatory compliance, that it's a major concern for mining operations. With this remote sensing data, you can ensure that the activities meet environmental laws and standards that right now are really the government are really focusing on these parts, and contribute, and of course that you contribute to the more responsible and sustainable mining practices.
So,
Any questions? Yeah.
yeah, on the pollution detection, can you talk a little bit more about that? What is that you're monitoring? You're monitoring turbidity of the water. What else? In the case of
You
water.
can monitor turbidity. For example, in case of water, you can monitor turbidity of water. There is also an index developed by the Mediterranean Oceanographic Community called MAGO Index, MAGO, that it has a lot of satellite-based indexes that you can have the chlorophyll of the water, approaches to chlorophyll of the water, turbidity, different algorithms to match the turbidity, the algae that are also in the water, and a couple of more different pollution related to water that right now I don't remember. But all these, I don't know. Yeah, all these ones you can have.
Okay, and on the biodiversity protection, can you talk a little bit more about that?
Yeah, for sure. You can just pinpoint the different parts of the area that surrounds the mining industry and the mining operations, the unopened mine pit, for example. And you can have, for example, in our platform, you can have alerts for different specific parts that, if, for example, if you are measuring the contamination of the soil, or for example, a simple one, the vegetation density in that place, and you are seeing the vegetation health, not the density, the vegetation health in that point, and you are seeing that the health of the plants or the vegetation in that specific point is decreasing. You can have alerts instantly to take care of that in that place. The health of the vegetation is being really poor, and you need to make something in order to avoid all this vegetation to die. For example, that's an example. The same with the water. You can monitor specific lagoons or so on to check for the turbidity along the time, and each new image that you upload to the system or the satellite pass through it, you can have alerts to constantly monitor if the water health or the water turbidity is what it should be.
Okay. And yeah, and also one thing that I want to say is that some of the clients use these alerts, for example, for illegal mining. That in some places is a big theme. because they made some alerts on the vegetation, and whenever the vegetation points they increase a certain level, it sends an alarm to the user, and well, that means that they are operating on their properties. So yeah, that's also another use case, a real use case, and right now we're having a lot of people doing this. Yeah.
They normally do it with the change detection algorithms that we have when the vegetation drastically change from that. They have the alerts and the measurement of the change, so they can visually inspect it and just for them to know if they have to go to the property or not.
So I'm just thinking, animal migration
Sure.
environmental assessment and monitoring. Did you have that?
I did.
Um, Migrations, like caribou migration paths, are usually in remote sites. It's something that is part of environmental monitoring or baselining, if you wish. Did you have? I mean, when I think about the frequency of the satellite imaging, um, I'm just thinking whether that your algorithm can be used in some ways to do animal migration path monitoring, maybe using drones or uh, something along those lines as a baseline. Because you, at the beginning of the project, you always do a baselining of the current situation at the site, and that will be used as the as a as a reference point for disturbance of the site from the environmental point of view. So, did you have that as a request?
Yeah, for all, for I think you are mentioning what is the baseline approach on having the alerts. For all of these kind of alerts, we also give, in order to create the alert, you need to have a testing period to know that you have to select it, to know the baseline values of the specific insights in order to later on decide the tolerance margins that you are going to select. And if you want to check out all the, for example, the values that goes above, the values that goes below, or just spikes or trends, change of the trend. But for that, of course, as you mentioned, you need to have a baseline testing, what we call the testing period, that can range for specific days. If you have a lot of drone imagery, for example, for the same week, or a monthly basis or quarterly basis for satellites in this part.
Okay, yeah. So yeah, I can imagine you can do a lot with that data after you collect. By the way, what is your business model? Do you offer your tools as a license, user license for per individual user or per group of users up to 10, so on and so forth, on a monthly basis? Is that how you are approaching the business side of this?
Are you answering that one, Sam, or I'll
No,
get it?
that's all yours.
Okay. Yeah,
That's
well,
all yours.
we basically work with processing points, and it depends on the total amount of data that the user process is the amount that we charge. All it depends on the place process it.
So
We
it's
don't charge for any kind of seats. For the company, you can add as many users as you want.
Yeah,
okay.
there we
So
go.
it's the data based. Okay.
Yeah, and also, well, it depends, because if you purchase a private injury, of course, it's gonna be a different price.
Okay. Yeah. So, and if you have, I guess, if you are processing a drone imagery, then it's going to be
Mm, it depends a lot in all the cases. So each case is a different word, you know.
okay. So, yeah, I guess at the beginning you do some assessment of what the data usage might be, and then you reconcile at the end of the month or something like that
There
after.
we go. we were like that. Like we first talk with the client and what are the needs of using our platform, and depending on the frequency, the amount of data, etc., uh, we will go for a package or for another different package. Yep.
Okay, very good. Thanks. Yeah, please, Sam, continue on.
So, just for the last one, the rehabilitation planning. This is where satellites also play, specifically satellites play a key role in rehabilitation planning. The rehabilitation planning, that is something essential on the mine closure, on a sustainable mine closure. I just forgot about sustainable mine closure. And the good part is is that satellites are meant to last for example, for 7 to 10 years, but they are constantly sending new ones with the same instruments to monitor through the years. So, for example, there are satellites like the Aster satellite that has been on site from 2001 up to now. So there is a lot of historic data, and there is a really good long-term monitoring. So for companies that are planning to have a sustainable mine closure and a good rehabilitation planning, this long-term monitoring on how it's evolving, or just to know if the rehabilitation efforts are being properly done or not, is essential. Also, in cases where further rehabilitation is needed, satellite again can pinpoint specific areas that require restoration. When I say satellites, I say also remote sensing, different kind of remote sensing instrument that leads to a better resolution allocation and, of course, a more effective recovery effort. Also, it also ensures the restored areas meet with environmental regulations. Again, this is not new. We need to get within the environmental regulations that those help mining to avoid compliance issues. That it's something also really important. Also, you can have post-closure assessment that are facilitated by these remote sensing data and allows the company to evaluate the overall effectiveness, for example, of the reclamation efforts, and it ensures that the land is left in unstable and sustainable conditions.
Okay.
So all of these, this was the example of on how it can help in all the different parts of mine life cycle.
No, that's excellent and very.
Nermina, I think you were.
No, it's excellent. I'm saying and very useful. I can think of 10 different possible questions and all the possible applications, but yeah, we'll just leave it there at the moment because yeah, people who are, all of us who are in the working in the mining industry certainly can come up with the applications that your tool can cover. Do you, how long you been I'm gonna say commercially available because I can imagine you've been in the development for quite some time. When did you go live from the commercial point of view? When did you put this product out on the market? Or products? I would imagine you have
Jaime, you know
Uh,
that?
yeah. Well, that's also a deep question because it depends. We've been working on this a long time. Well, not myself because I'm not the founder, but the founders started creating this like 5 years ago. Was Sam, right? And
Yeah,
yeah, and they've been developing,
2020,
learning from
around
the market.
2020.
Yeah, and learning from the market and well, gathering different information until we got like the products that we have right now. And yeah, and we will keep developing until we get all the uses here in the mining industry.
Right.
We
So,
started around 2020. Around 2020,
mhm.
and we have what we call just working in the inside the cave, just by developing and listening feedbacks for real mining companies, and we launched the first stable version in 2022. Right now we have two products, Remote Miner and Remote Enviro, in this part that you can access through the web or through an API. But again, the software world is a world where you never stop developing. The only difference is that now we have a lot of, now everything that we develop is based on our main clients, that constantly we have meetings with them and we develop features for the peoples like them, for the companies like them.
Excellent. So basically, for 2 years, you have the product commercially available, or maybe 2.5, or
Yeah.
something like that. Okay, very good. What do you see in terms of usage? What's the focus of your client side? Is it on the environmental side or on the exploration side? I'm
What
just
I
curious.
find, the personally, what I've seen here on the time that I've been in Toronto and talking with clients and their thoughts and needs, in the area that they are most interested on is on exploration.
Mm-hmm.
Is crazy. It's like we're always like they are. Where is the goal? And that is the area that they are more interested on. But whenever we show the platform and all the needs that they are on this type of technology, they realize that they can use this type of technology for more aspects. But the first interest, in my opinion, is exploration. Yeah.
Okay, very
Yeah,
good.
right. And like Jamie said before, one unexpected, really good interest was on detecting illegal mining. That we are seeing it more and more, and that's something that we didn't expect. And we started to develop those things based on the client needs, and now is one of our main focus also.
Very good. Okay, so I'm going to invite our guests to pose the question if they have any in the chat room. And in the meantime, so you are operating, your company is based in Spain. Jaime is in Toronto. So do you target Australia, for example, and African clients?
Uh, I get that one, Sam.
Yeah, all yours.
Yeah. Well, as I said, I'm the head here in Canada, but of course we got different teams, and we got teams that they are aimed on Australia, Africa, and the rest of the world. You
Mhm.
know, so yeah, we try to get into that markets.
Okay.
Furthermore, our main clients are based in Canada, Australia, and South Africa. That's the three most hotspot countries for mining.
Excellent. Very good. Okay, I haven't seen any questions yet, but is there anything else that you would like to bring on before we close out?
I
Is there,
don't
is
I
there
don't think
anything
so,
that
right? I think
I think that
Sam
was
got almost well. Mm, no, I think Sam got almost everything done.
actually I have one more question. Can
yeah.
you can
Hey,
you
Romina.
tra- can you track Santa? You know Santa. There is a NORAD track Santa. Can
We
you
can do
track
that, of
Santa?
course. Like there are some crazy satellites.
Exactly. Okay,
Oh
guys.
yes.
This was really insightful. As I said, your clients are always coming up with the new applications, and I'm sure anybody who's going to see this is going to come up with its own application. I would like to thank you for your contribution. Thank you, Sam, for staying late.
Thank you very
Um,
much.
yeah, you can go for a party now, I guess.
Oh, I'm going for the bed. Tomorrow we have a lot of work.
Exactly. Okay, thanks a lot. All the
Thank you
best,
very
Thank you,
much,
Nermina.
Christina.
and we'll be in
Thank you for
touch.
having us. See
Absolutely
you.
pleasure.
Bye.
Bye.